the Titan Submarine. Really want to make a science-driven mission. We're talking all the way back from Saturn. It's a long distance. So why a submarine? It provides much more efficient mobility. You could put something on a little cable and dangle it down. But that's going to be a lot of energy to drag that around. This thing's going to give you a lot of space to go. As you'll see, these seas are very large. We're going to go thousands of kilometers. We want to go above and below the surface. So a lot of different ways on Earth that you can build submarines, a lot of different shapes. Big, thick spheres, saucers, whatnot, cause a lot of drag and be a lot more energy to keep us moving, going at a good clip. So in the end, we did pick out we picked the long, skinny cylinder, the normal submarine shape that you like to see. So here's the submarine itself. Here's the science. There's a surface science, so meteorology station here and a surface imager. Up high, we want to be able to see kind of as far inland as possible. A light and a camera for when we're subsurfaced. Physical properties to basically bring in the fluid and analyze that as we move along. Depth sounder, and then of course the side-looking sonars, which looking down with the ship is nice, but looking sideways you can get a lot more visibility there. So, and so that's the science packages. Launch, and probably around 2040, get there around 2047. We want to get there the next summertime. We'd like to have as much light as possible. And it turns out the light would be on, it would be basically sunshine all day long. It looks like 10 minutes after dark around here, but still the sun's up. The Earth would also be right by the sun, so we'd always be able to communicate with the Earth all the time. And that was very nice. The navigation, there's no magnetic field, so there's no compasses, which is kind of a bummer. So when we're surfaced, it's fairly easy. We always know where the sun is, and the Earth will be able to track us and tell us where we're at. Submerged, a little tougher. We kind of borrow from terrestrial sources. There's a Doppler velocimeter, which basically bounces off the seafloor and basically tells you how fast you're going and whatnot. We want to keep our position fairly well tracked and roughly within a kilometer. So every 8 hours, we're still within a kilometer where we think we are.